We'll start today by the summary of the two breakout sessions we had yesterday. So with that, I'll hand it over to Shuyi and Adrienne.
Okay, thank you, Anish. Hi, everyone. So we had a really active panel, four really nice panel presentations, and a large group, very engaged people for discussion. So next slide, please. Here, we're gonna provide a brief summary what we have discussed, and according to the guiding questions given by the organizing committee. So there's three areas that sort of emerged as an important area that needs to be measured in order to improve our understanding of prediction, not only tropical Pacific atmosphere, but perhaps have global implications. The first is marine boundary layer. The panel expressed a great urgent need for better understanding the thermodynamics and dynamic process that including measurements of profiles of temperature, moisture, and wind. We also would like to have measurements in terms of vertical velocities within and across the top boundary layer. And also complication introduced by cloudy boundary layer. These boundary layer measurements would be really important to cover a wide range of a time scale from minutes to hours, diurnal to subseasonal scales, and beyond. The second area is a long-standing problem in the tropics. That is the convection environmental interaction across the scales. So this has been sort of measured for a long time over many field campaigns, but on the higher frequency and the clouds near environment and the transition to a large scale and things, it has been a really complicated process. So we would like to start with the convective life cycle that understand how initiation of scale growth and dissipation, that how this interactive process occur. And also the convective interaction with the large scale. As we all know, tropical convection, unlike in the mid-latitude, tropical convection, small scale can drive large scale circulation. So that upscale grows into interacting with a synoptic basin scale, planetary scale, cover all that variability is very, very important. So currently models having difficulty to make a transition from convectively active phase to convectively suppressed conditions. So MGO being a good example of that. Especially the low level humidity buildup process seemed to be really a challenge. In addition to that, we also discussed the non-precipitating cloud environmental interactions and also process control the rain rate and amount at a very high column water, integrated water vapor. So third area is the clouds dynamics and the microphysics. This again is another area that as we are going to higher resolution, so the microphysics parameterization has been tackled for a long time. And so we all know that the parameterization can be done with very unrealistic cloud dynamics. For instance, you can have 1 meter per second updraft over a very large area and still produce hail, which is not something that happens in nature. As we're going to more clouds permitting resolving models, we really have to start to tackle the convective updraft, downdraft velocities and the size and how they work with the macro physical properties. So next slide, please. Yeah, how do we do that? And so we have a lot of discussion go on to describe, what kind of measurements we will need, and especially in the context of this question about air-sea boundary layer, in ability to really simulating the coupling process. So again, we would like to get high frequency measurements of a marine boundary layer, sea states, surface winds, and upper ocean state variables, such like SST, salinity, and so on, over time for better understanding and improve, especially coupled atmospheric models. So going forward, it's really important to take into the context of these measurements for coupled model development. So complexity of a marine boundary layer is unique and not well sampled. So as most of you know that boundary layer parameterization has been developed based on the data from Kansas. So often the model been taken from the Kansas over to the ocean without a whole lot of new improvement things. So now we realize that it's part of the shortcoming. So we needed this complexity measurements over a long time. So need routine observation for data simulation, model verification, and improvements. Observation need to be better constrained with the cloud dynamics and microphysics. As we said, we can have the scanning dual polarization radar, wind profilers, and so on and so on. There's quite a lot of emerging technology that we can tap into. And also we need observation to constrain vertical entrainment profiles. So here again, the updraft, downdraft measurements throughout the convective life cycle from the convective stage to the stratiform and cover the entire mesoscale convective system life cycles. Next slides, please. Here. So we have discussed quite a lot about options, what kind of the emerging technology we can tap into. And many of these, the list here is so dream platforms. So it's certainly not meant to be exhaustive list, but we did discuss the possibility have floating platforms to host multiple observing systems, including flux towers. And there's discussion about tap into the renewable energy platforms in the future, working with industry and so on, so on. And also new development of motion stabilized Doppler radars, LiDARs, and dual polarization scanning radars, and so on, that can be used on the mobile floating platforms. And also aircraft remote sensing, including radar, LiDARs, and many new development in terms of air deployment, deployable devices, including the traditional drop zones and the new uncrewed autonomous systems that can be dropped out from the large aircraft, and the drifters and surface floats and so on, so on. So this allow us to observe not only the atmosphere, but it can deploy things in the upper ocean as well. We also discussed the surface-based measurements, up-looking profilers in terms of getting the temperature, water vapor measurements in the boundary layer. And of course, ships still should be in the mix. In the many situations, we'll need ship to take certain measurements and also surface some of the floating platforms and so on. And satellite. So satellite observation is always going to be important, but at the same time, we rely on a lot of other things that needs to be launched in the space. But in particular, we would like to see the future that differential observing radar LiDAR that as NASA is planning for the ACCP missions, and also some of the planned mission for scalemeter measurements that taking simultaneous measurements of surface vector winds and the surface current. We did discuss the possibility of getting better atmosphere budget studies in terms of all the moisture, heat, and so on, so on. But this has been really studied in many field campaigns before, and especially the first one is over tropical Pacific in the 1956 in Marshall Islands. This paper, the classical best paper we ever had, 1973 sets up the stage of how this thing has been done. Ever since we have done this in GATE, and every 20 years we have another big field campaigns. However, for the smaller scale that we need for the collective budget and things, it's much more difficult process and to measure. So jury is still out whether we can do that, how well we can do that, but we fully appreciate the difficulty of getting that in terms of a budget. So anyway, I'll stop there and pass over to Anne.
Yeah, great.
There they are. I'm not sure. I don't know who's sharing them, but magically they appear.
Paul. Okay, great.
Yeah, so I want to thank our note takers, Deng Xiao and Kyla for doing that. It was really great, and the 50 people who were in the breakout. We had a great discussion. So, like the atmospheric conversation, 3 main topics came out in the process question: pathways that get to the surface, mixing in the cold tongue, and then natural variability versus long-term change. And for pathways, we talked about how the transport of heat and biogeochemical parameters are related to the tropical interior circulation, low latitude western boundary currents, and the Indonesian through flow, and talked about how these pathways not only respond to enso and decadal variability, but can affect those processes, and they're poorly measured. We talked about using tracers for this, but then we brought up a question of, what do you do when the tracers are active, like when salinity impacts circulation, and how do we disentangle that? In addition, for using like oxygen or nutrients as a tracer, the biology is modifying those as they move along that path. So how do we disentangle that? We also talked about how surface to subsurface connections are impacted by mixing. So mixing is another important part of the pathways question. And at the surface, currents as well need to be part of that too, because they impact the flux exchange estimates. So what's happening when the water is moving along that path and gets to the surface is impacted by the current. So all of this is connected. In terms of mixing, we really need a better understanding of the fine scale structures and drivers that happen along the thermocline across the Pacific. And this connects with some of the multi-scale interactions conversations that we had on the first day with regards to MJO, westerly wind bursts, how they're linked to mixing and the subsequent air-sea interaction. And then we talked about how mixing is also an important term in the warm water volume budget and really key for that prediction question. And then in terms of teasing apart natural variability from long-term change, the records have to be long. Models tell us they have to be particularly long in the tropical Pacific, and TPOS is well positioned to provide those records. Next slide. So in terms of models for themes, we primarily talked about surface waves, the importance of high resolution models, carbon export, and OMZs. So surface waves have a big impact on mixing and flux, but they're not well represented in models. And that interaction has to be better observed to improve our algorithms. That wave discussion here is also relevant to the innovative technology question that was asked at the end, because there are new satellite-based wave and current measurements. So we need to be able to constrain them better. High resolution models, of course, are critical for constraining certain features, that we've been talking about the last couple of days. Models diverge significantly in carbon export. There's just huge uncertainty there. And we really need process studies that better connect satellite ocean color at the surface to what's happening, what's actually exported below the mixed layer. And then there's also a bias in the models in terms of long-term change in the oxygen minimum zones. And it's not clear whether that's related to the physics or the biogeochemistry in the models. So that's an area of really active research and lots of questions there. Next slide.
Adrienne, 2 more minutes.
Okay. Yeah, we can skip this one because we actually had a really cross-disciplinary conversation. So in terms of innovative technologies, we talked about direct air sea flux measurements. So from surface, from super sites that Carol Ann talked about earlier, and then also how to get stress flux from scatterometers. We talked about co-located measurements, of all the things that I've mentioned previously, and we can do that using a lot of the new technologies like USVs, moored profilers, swift drifters, and floats. We talked about using floats to constrain subsurface currents that capture the whole, and also to capture the structure of OMZs, and so the TPOS2020 plans will be great for that. And then there's new satellite measurements coming online, and we talked about the importance of getting in situ data to validate them, particularly with the current measurements. The wave measurements. Next slide. Other themes that emerged, this was mostly in the chat and things we didn't get to really discuss in detail, but the value of seawater isotopes and the variability and processes that connect the subsurface to deep waters still remain mysterious. Next slide. And then I don't necessarily need to walk through these. These were mostly captured from the innovative technology slide. So implementing these observations would be next steps.